Hello everyone, this is Zishan Akhtar. Hope you all are fine. So please be safe at your home and support this lockdown. But I see this as an opportunity for all of us to learn new things. For the same, today I am sharing this small video on gravitational force which we all read in class 8, 9th and 10th. Although the topic is very basic, but its clear understanding will definitely going to help you in exploring the related area. So today we are going to talk about gravitational force. You all must have heard about this famous story about Sir Isaac Newton and apple, that he was sitting below a apple tree, then an apple falls on the earth. So he was amazed why this apple comes down to earth, why it doesn't float in the air. So this is where this all concept of gravitational force comes into his mind. And after studying a lot, he in 1687 he proposed a law about the force of attraction, which we call as a Newton's law of gravitation. So Newton's law of gravitation. In fact, Newton was a very great scientist, and not only in physics, he has given many important formulas and rules and theories in mathematics, in science, in astronomy, in everything. So I hope most of you, the people who are listening this video, belongs to 8th and 9th and 10th class. And if you enjoy science, I want you to start focusing on mathematics, because literally, believe me, if you are good at mathematics, you can explore any field in the future. So let us start without much delay. Let me start what this law is actually. So what this law says, that every mass on earth attracts other mass, and this force of attraction, so say this is mass m whose weight is m, and this is another mass whose weight is m. So both this mass will attract each other with a force F, and this force of attraction will be proportional to the product of mass of both the object. This is multiplication. So this is mass of first object, this is mass of second object, and it is proportional. What I mean by proportionality is that when I will increase this m, then F will also increase, or when I will increase this m, this F will also increase. So this is directly proportional, and this force is also inversely proportional to the distance between them. What is that? So these are two mass we have, and this is distance d between them, right? And they are experiencing force F due to each other. So what I mean by inversely proportional, that when this distance will increase, that is, when this will increase, this force will go down, right? So what Newton did, that he said that we can combine these two equations and we can write it in this way. Here this g is nothing but gravitational constant. In fact, it is also called universal gravitational constant because it is constant everywhere in the universe. And its value, this g value, was founded by Henry, and he found that this value is nothing but 6.673 into 10 to the power minus 11. Now everything has its SI unit, we know. So what we have g m by d square. What is the SI unit of force? We all know it is Newton, denoted by N. What is unit of mass? It is kg. This is also mass, so it will be kg. And distance SI unit is meter, but we have a square here, so we will have meter square. So here we have kg square upon meter square. So now you can see, we can write g is equals to, if we take this d to here, we will have F into d square upon m into m. So what will be its SI unit? It will be Newton meter square per kg square. So you don't have to remember this, you can directly find this SI unit of G as, so what we have, G is value is 6.673 into 10 to the power minus 11 Newton meter square per kg square, right? So this was all mathematics behind this force between two objects in universe. But actually in real life we always feel this force. In every moment we are feeling this force. So you are standing on earth right here, and why you are not floating into universe? This is because of this gravitational force which is binding us with earth. Also you have seen this, that moon revolves around earth, right? So why it's revolving around, why it's not floating somewhere else? This is because earth's gravitational force. You have seen that all the planets revolve around sun. Why they are revolving around sun? This is because of the force between them and sun, right? If you go to beach, you must have seen these tides in the sea. So but these tides are very they become very aggressive and very high in full moon day. So this is because of the moon's attraction toward this ocean. On full moon day this moon is full, so that's why this force is high, and that's why we have very high tides on full moon day, right? So this was about the gravitational force and the Newton's law about gravitational force. Now we will talk about something called free fall. What I mean by free fall is that when you drop on an object on earth, you are not throwing it, mind it, you are not throwing it, you are just leaving it and it's getting dropped on the earth. Suppose you are just dropping a stone. So what the formula is, F is equals to G, which is nothing but the gravitational constant, then mass of earth, because you want to calculate the force between that particular stone which you are dropping and earth. So we will have mass of earth and mass of stone. Say this has mass of, this is mass of stone, and suppose the radius of earth, radius this much, I'm talking about this much, is RE. This is diameter and half of it is radius. So radius is RE. So distance will be RE square, because in formula we have D square. So here we have RE square. Also from Newton's second law, we know that force is equals to mass into acceleration. Here this acceleration is because of earth, so we will give it a name, we will put it as small g. So we have force is equals to m into g. This is nothing but gravitational acceleration, right? Its unit is same, meter per second square. We all know that acceleration has unit of meter per second square. So what we can write from, say we have this equation number 2, this equation number 1, force is gm m by re square and force is mg. So we can write mg is equals to gm em upon r square e. So simply we will cut this m, so my g becomes gm e upon r square e. We know this value, this is 6.673 into 10 to the power minus 11. Mass of earth, this is mass of earth, which is 6 into 10 to the power 24 kg, and this is radius of earth, which let me write it, radius of earth, which is 6.4 into 10 to the power 6 meter. So what will be g? G will be 6.673 into 10 to the power minus 11 into 6 into 10 to the power 24 divided by 6.4 into 10 to the power 6 whole square. when you will solve it, you will get G is equals to approximately 9.8, and I have already said that this is its unit, so it will become meter per second square. So this is gravitational acceleration. So today we learned two things. One is capital G, second is small g. This is gravitation. Oh, let me write it again. Gravitational constant, and this is gravitational acceleration. Its value is 6.673 into 10 to the power minus 11. Its value is 9.8. What is its SI unit? SI unit is Newton per kg square meter square, which we have already found, and its value is meter per second square. So these were two small things which we have learned. So one thing I would like you all, that here I have used mass of earth. So this should amaze you how scientists have found this value. क्या कोई बड़ा सी तराजू है जिस पे रख के हमने अर्थ का मास लिया था, वेट लिया था? Obviously not. There must be some scientific way which they have measured and come up with this value of 6 into 10 to the power 24 kg. So I would like you to just give a Google search. You must all have this internet connection. So just give it a Google search, how to weight earth, how to find mass of earth or something like that. You will get the answer. Okay, so that, and one important thing, this is scalar. Scalar, that means it doesn't have any direction, just a magnitude, just some value 6.673. It's a constant. This is also constant. Small g is also constant, but it is vector. Why it is vector? Because it has some direction along with magnitude, right? So that was all for today. In the next video I will try to discuss the three equations of